Let's welcome Geoffrey Shmigelsky today, who is the CTO of OneCup AI for today's AI seminar. So Geoffrey has a distinguished career leveraging cutting-edge technologies with several startup exits. His accolades include Entrepreneur of the Year and Associate Founder Singularity University. He holds a master's degree in computer science from Georgia Tech, specializing in artificial intelligence and deep learning, a lifelong learner actively seeking opportunities to deepen his knowledge in a range of subjects. So I think we have a great deal to learn from his experience and work at at OneCup AI. So with this, I give the floor to Geoffrey. Thank you so much for coming today.
Thank you for that awesome introduction. I feel flattered. And all of you, thank you for having us today. It's great to be able to explain what OneCup does and show you how we do things. When I'm giving my talks, I like them to be two-way discussions. There's more than just a lecture and you listening. If you have questions during the talk, please bring them up. We're going to be doing a pretty in-depth talk here. This isn't not going to be some watered-down talk. I'm going to spend about 10 to 15 minutes talking about what OneCup is and our business and who we are. And then I want to dive into the tech. And the tech is much more interesting from a computer science point of view. I'm going to show you how we actually do face ID for animals and how we build everything else that we do at OneCup. It's pretty amazing. And with that, I'd like to start sharing my screen. Now, when I do this, I can't see all of you at once, at least not easily. So if there is, let me just see if I can fix that. If somebody has a question, please put it in the chat and I'll try to address it on the spot, okay? Sounds good? All right, so to begin, OneCup AI. We do computer vision for animals. That's what we do. We use computer vision, state-of-the-art computer vision actually, to track everything on an animal that we care about. And we can do it for many species at the same time. What you're looking at in front of you is BETSY, our bovine expert tracking and surveillance. And we have a different AI for every species that we do. BETSY is for cattle. And what BETSY does at a very high level is she takes an animal and cuts it into boxes from the background. And then from there, cuts the individual animal into unique boxes for the head, body, tail, and so forth. And BETSY then draws these dots called key points and then classifies the activity of the animal. And we do this at a phenomenal rate. And right now we are processing in the cloud about 20 to 25,000 videos a day. We're not just some startup. So BETSY does basically this. And I want to show you why it is so important that we can do this and the applications of us doing that. Our company is called OneCup because we want to manage a herd of animals over a cup of coffee. Ranchers love to sit in the morning, have a cup of joe, much like this one. And you're my third talk of the day, so my voice is going. And what we do is we want to help people manage their herd using computer vision. Our company was formed a couple of years ago. We've raised well over $1 million for the operation. We are currently 12 people, soon to be 20. We are growing quickly. And we're based in Vancouver. We have 20 beta sites right now, and we are activating customers as we speak. The problem with the ranching industry, the problem that we are trying to solve is simply that the industry is stuck in many ways in the 60s or the 70s. It hasn't changed much in 50 years because they cannot easily adopt technology given their location. There are a number of hurdles that are quickly being removed. But right now, ranching is still largely a manual operation without a lot of technology. Not in the way that you would think in other areas like you see in medicine or even in crops. Ranching is tough. There are not enough people, it's hardware-based, and it lacks automation. With computer vision, you can create an AI that acts as the eyes of the rancher. A computer can become the eyes of the rancher and do what a rancher does, but because it's silicon, it's done, it never sleeps, it never texts, it never gets tired. It just watches all the time. And in doing so, it can watch all the animals 24/7. That's the power of computer vision at the ranch. The market for this is enormous. There are 5 billion livestock in the world, another 2 billion pets, another 20 billion poultry. And we are doing all these industries at the same time. Our most commercial product today is cattle, but sheep, swine, and goats are not far behind at all. In the cattle market in Canada, if you're curious, there are 10 million beef and 2 million dairy cows. And Canada is only 1% of the worldwide market. The market is enormous. The market itself is broken into different groups. There are feedlots, large suppliers and small suppliers. But in Canada, there's roughly 60,000 ranches, of which all of them will be our potential customers. This is what we deploy at the ranch. At a ranch, we deploy cameras that look a lot like this one. And these go onto a ranch, we ship them out. And they connect to a central computer that we put either on site or in the cloud. This computer processes the video feeds coming from the cameras to draw those dots in those boxes that you just saw. And these cameras are quite inexpensive these days. And the edge device that we use is quite powerful. It runs today at the low end of the equation, 20 trillion operations per second, and can simultaneously handle 16 cameras. We run BETSY on the edge device, or we run BETSY in the cloud. We do both. But BETSY is a series of cameras and basically a bunch of compute power. And we deploy these cameras or use cameras at the ranch's site to watch animals. It doesn't matter if it's a sheep barn, a swine barn, or an outdoor pit field, like in the case of beef cattle. Pretty cool, right? This is what BETSY looks like in a hardware point of view. BETSY can do a whole bunch of really amazing things with computer vision. This is the value that she provides to the ranchers. She can tell, for example, when an animal is calving, when it's showing signs of labor, the delivery process, and even the colostrum uptake. We can tell if the animal is getting lame. We can ID the animal for tracking and shipping. We can do a whole bunch of things with computer vision that helps a rancher run their ranch. We do all these things, and we are rolling these out all very quickly. Our users don't see any of the technology. They see this beautiful user interface that lets them process and analyze their cattle either at an individual level or at a herd level. This is what our user interface looks like. Our platform consists of growth, health, phenotypes, activity, and nutrition. And our company is growing quickly. We'll be profitable easily in 2022. And the worldwide market is enormous. We estimate we'll generate about 12 million in revenue from Canada alone, and much more as we scale up across the world. We have a really quite an amazing business in front of us. But the real question, if we go past the technology, the business of the OneCup for a second, why now? And this is an important point of my talk. Yes, we can create a great business out of OneCup, and we can take that business to a global scale. But what happened that made it possible now that made it not possible 2 years ago? Why today? You see, I'm one of the people behind an organization called Singularity University. And at Singularity University, or SU, which is based down in California, I'm an associate founder. And at that school, we teach the power of exponential technologies to change the world. Specifically, how exponential technologies can affect the lives of 1 billion people within a decade. I think OneCup is one of those potential companies. At Singularity University, they have launched many, many companies, of which some have gone on to make big impacts in the world. And you see technology changing and impacting companies and entire industries across the board. For example, look at what Tesla did to the car industry. They've gone from being, well, frankly, in many ways, people thought it was a joke a decade ago, to being a company that's now worth over $1 trillion and the leader for basically a whole fleet of millions of robots on the road, using the power of artificial intelligence and solar or battery-powered cars. The same thing is about to happen in the ag tech industry. Technology is changing, and because of it, it'll disrupt the industry on a massive, massive scale. Cameras are doubling in power every year. Edge computing is increasing anywhere from 2x to 7x a year. This is 200 to 700% per year is happening right now with edge compute devices. Starlink is about to revolutionize rural broadband internet service. These are converging that make it possible to use technology to change an industry. Look at Starlink. This is a great example of this. They have 1,700 satellites in space right now. They're launching 60 every 3 weeks today on reusable rockets. The last generation of the satellites could do 18 gigabits per second on one satellite. The current next generation of the satellites, which are being launched today, have lasers on them. These lasers act like fiber optics in space. And because they're actually going through a vacuum, they actually work better than fiber optics for latency. When you launch thousands and thousands of satellites in low Earth orbit using reusable rockets, they're launching, they claim up to I believe it's around 40,000 satellites when they're all done, 12,000 in the next several years. It'll cover the world with broadband internet. This is really important because at a ranch, they don't have broadband internet. They only have 2 megs up. Starlink increases the performance at the ranch by 10x, and it's global. So now all these millions of ranches around the world now have high-speed internet. That's a huge game changer. And for companies like us, it's how we go global. Starlink is going to change the game. But it's not just Starlink. There's something else fundamentally happening in computer science, which applies to what you guys are researching. Look at this graph here. This shows the growth of compute power in relation to human intelligence and other animal intelligence, given what we know today. And as computers become running at petaflop speeds and even higher, and edge devices can run at teraflop speeds quite easily, which they can today, it's very possible to create cars that can drive better than humans, and that's what's happening now. It's very possible to create computers that can see better than a rancher can, and that's what OneCup is doing. But if you think this forward, let's say a decade from now, you can see how computers can outperform humans across many, many aspects of what we take for granted today in their professional fields, let's say in diagnostics, in analyzing text, which you now see with the large language transformer models, and so forth. And computers are very quickly approaching what humans can do at faster than human speeds. And as you plot this forward, the implications are simply profound to many, many industries, especially in the areas of automation and soon to be in the areas of robotics. Today, computers are bordering on, in a few years, the speed of the human brain. And if you take that forward, of course, of another decade or so, you now see computers replacing the computational power of one human brain by factors of 10, 100, and even thousands. The implications, if you just sit back and think about it, are profound. It'll revolutionize industry after industry after industry. Being in AI is like being at the center of a giant storm that is coming, which is going to just wash over what can be done in the world today using automation. Combine that with high-speed internet on a global scale, powerful edge computing, and in our case, crazy good cameras, you can basically disrupt ranching. And we call what we're doing here precision ranching. So that's what's happening today in tech, and it applies to everything. But in our case, I'll show you how we use it here at OneCup. Now I'm going to stop here. Are there any questions about what I showed you?
Geoffrey, I only have one comment, and is that I guess I buy everything you say mostly. So for example, the diagram you have up is important to give us some sense of impact of scale for sure. One of the things that's sometimes missing, especially from the so enthusiastic proponents of Singularity University, are a distinction between what computers do well and what humans do well. Does that factor into the sort of the subject matter expertise for your trajectory of OneCup?
Not so much. So Randy, you do bring up a really good point. For our case, because we're simply doing straightforward classifications of animal behavior,
right,
this graph largely holds true.
Okay.
For example, the last generation of NVIDIA's edge computing ran at 20 teraflops. Today's generation, which is coming out next quarter, runs at 200. So that is largely true, but it does bring up a really good point. Computers are not humans. And what they lack specifically is context. They don't have in my case and in your case, 50 years of contextual learning and interacting with the world, and all the mistakes that we've made. So the things that we call common sense, they lack. And they are still far away from having common sense. But nonetheless, in this,
No, that's a great
Sorry.
answer. I think that that's on the right trajectory because it keeps the credibility of the value of what you can do with this trajectory of technology, but doesn't artificially inflate it with that convolvement of human versus machine. The only other question I have is that the specificity or the level of detail of the classification of animal behavior is intriguing. I have a good friend who spent his life as a neuroscientist instrumenting cats to be able to understand animal locomotion. And he would be intrigued by what the next refinement is. So, for example, to create observations of a cat moving on a trajectory to be able to predict neuronal stuff when they instrument these cats would also be amenable to what you're doing. So I think that trajectory of OneCup is a wonderful animal physiology project.
Yeah, very much so. I would agree. We've been doing a lot of work actually with dogs and other species, and it's quite fascinating. And I'll probably show you a video of what we do for dogs. But yeah, absolutely. Perhaps you could put us in touch with them. We'd love to have a conversation. We're always looking for partners and people that we can work with.
Okay. Thank you.
But go ahead.
No, go ahead. I don't want to delay you anymore. You and I, our conversations that we've had could go for hours, so I'll just pause.
Okay. So turning our attention back to OneCup, we'll leave this bird's eye view of artificial intelligence for a bit here. But the point is that we're basically taking advantage of exponential growth curves. OneCup isn't trying to take out a traditional market. We are taking out a new market created by technology, okay? We're basically going into a greenfield market, and we're doing that because technology is changing the game. Technology will change the game in many, many industries, from insurance to car repair to you name it. And thereby, the opportunity for people that are experts in artificial intelligence is simply massive. Now, that being said, let's talk about OneCup. This is one of our dashboards that we have at the company. And what we show here is these are some of our beta sites. We have currently 20 beta sites across Western Canada. Everything from ranches to bison sites to sheep sites and even one elk site. And we have hundreds of cameras out in the field today that actually are monitoring animals, and we're adding more every week. What we do is we basically collect footage. These are our beta sites, and we collect footage from these cameras, and we all process it either at the edge or in a cloud pipeline. What that looks like from a customer point of view is if I click on, this is one of our video portals, we take our videos and organize them into 1 hour videos. Cameras upload a lot of footage. Like I say, today we're processing 20,000+ videos per day. And people can go in and watch those videos quite easily and look at what's going on at any one of the cameras. Our AIs do exactly the same thing, and you can quickly use computer vision to process the footage that is coming in. So the eyes of BETSY are cameras on the ground. And these are the kind of videos that we take in. We have millions of these videos stored right now in the cloud. And we are processing them as we get around to it. When we process them, I'll show you what we actually do with these videos in a moment, but this is what our input is into our models. What we actually do with this data is this. This here is our computer vision pipeline, or at least part of it. I'm not showing all of it to you here. But BETSY consists of 5 main layers. We filed a patent around this. And what we do is we show how BETSY actually works right here. BETSY in the first layer detects if people or animals are present. In the second layer, she draws these bounding boxes for each species. In the third layer, she draws these key points. In the fourth one, she determines the ID, which I'll dive into some more here. And finally, she does what we call classifications, where she tracks everything from activity to breed to certain phenotypes to calving indicators. Okay. What that actually looks like is as follows, and this is where we're going to get into the computer science stuff of it. So again, please stop me if you have any questions, but this is the brain of BETSY, and we think arguably she is one of the most advanced AIs that exist in the world for livestock. Level 0 looks like this. On level 0, we run segmentation masks and detection to see if animals exist in a video. Here we're demonstrating that we can see through a railing. And one of the key things you guys want to take away at this when you're watching BETSY run on level 0 is that they're what are called confidence scores. So as you know, AI is quite often to predict with confidence scores, especially in classifications. Here we're showing that BETSY is 88% sure that this is indeed a cow. And as you can see here, as we scale up and these animals run around, BETSY's confidence score goes up and down based on how close the animal is and how much it's jumping around. This is cattle. This is level 0. Here's level 0 for sheep. Same idea. We're determining the confidence score of animals. We're also counting how many animals are in the scene. And we can see here that we have not only bounding boxes, but segmentation maps for animals as well. And the animals, this actually runs pretty good. Once we have that, we then take the animal and we cut it up into boxes. Here we use these boxes to determine what the knee is, what the tag is, and what the head is. And in doing so, we can track specific parts of an animal. And we can do so at the herd level here. So you can see here, we can see the nose, the hooves, the knees, and so forth, and the tail of the animals in question. This runs at full frame rate. Once we have the bounding boxes, which if you go back here, consists of level 0 and level 1, we then do this something here where we actually draw, we also do the same thing here working for pigs. Here's an example of it working for pigs. Remember I mentioned that BETSY, that OneCup is a multi-species company? We certainly are, and here we're doing the same technology applied to swine. And the value of this is that there are different use cases in swine as there versus cattle, but the same core underlying technology can drive and provide value to both types of customers. For example, if you look here, we can count who's eating first, who's eating last, how often the piglets are eating, and look at, for example, what the sow is doing and making sure that they're all getting enough nutrition. Okay. And we track all this information into giant databases. When we run our system at full speed and at max settings, we think this is just an estimate, but we think that with animals being visible in a scene, that a single camera will generate up to between 100 and 200 million points of data per month if we actually do it on every frame of video and animals are present. We dump all that data into giant databases for further analysis. One of the consequences of what I'm saying is that using computer vision, we're becoming one of the world's potentially largest repositories of animal information, all accumulated using computer vision. The implications of that are enormous when you're trying to optimize things like genetics, or even trying to optimize the feed efficiency of your herd. Once we have the bounding boxes, we then compute things like the key points. And here we have, for example, key points. And again, you can see here, as we draw these key points on the bone structure of an animal, we also have confidence scores yet again. And those confidence scores tell us how accurate we think those key points are. And of course, we can do this on as many frames of video as we want. Now, as you see here, as the animal moves its ears, for example, or as the animal walks around, we actually can track the points of the animal from the head all the way down to the tail. So we have the key points that make up the animal. We also can compute the angles between those key points. And you see the same animal here with that same technology applied, minus the confidence scores. And we can compute the angles, and we track that information on a temporal basis to track things like lameness. Pretty cool, right? So we have these key points that are actually going through and indicating how animals change over time, how things actually move on an animal. Again, I realize this is pretty advanced, but we're doing this as one part of a giant pipeline that you all see here. Once we do that, we then start running the ID algorithms. These actually give us the identification of the animal. And just to recap, the ID is level 3 of BETSY's AI pipeline. Here we're reading the drop tag. So all animals have an ear tag that tells the human who they are. And what you see here happening is that we're reading the drop tag 223D with, in this case, with an 88.9% confidence score. As I play the video, you can see that our confidence score goes up and down as we read the drop tag on every frame of video in this case. And even as the animal moves away and the angle of the tag changes, we can still read it. And one of the beauties of having a confidence score is we know when to ignore the data, the model, the predictions of the model. We can see that when the confidence is low, we should ignore the value because, well, it could be wrong. And here, she's dead on. She's 100% correct. So we put a lot of work. It took us months to figure out how to do this well. But we can now read the drop tags with a high degree of reliability. We think so anyways, as they're written by hand. But there's a big problem with drop tags. And the problem with drop tags is one, animals lose them. And two, they're small. So they're hard to see on video, especially if the animal's far away. So another aspect of BETSY is this. We've done Face ID for animals. Just like your phone can tell who you are, we can tell who an animal is based on how they look. What this here is called an activation map. It's not a thermal map. This is not a heat map like you see in a thermal camera. This is what is called an activation map. This tells us what part of an animal's head is unique that gives away the ID. And you can see here that in this case, the space between the two eyes uniquely identifies this one animal from its peers. Face ID for animals. And lo and behold, if we ask BETSY to draw how she identifies the animals uniquely, and this is how she does it. And she's showing us what part of the animal is unique when she does so. And using the Face ID, she's 100% sure that this animal is 223D. And this is what we filed a patent on earlier this year. Actually, last year is when we began the process. And Face ID for animals is very real. And we can do it with a high degree of accuracy. Now, once we have the ID of the animal, we now have two ways to ID it, for sure. And we do similar approaches with other parts of the body of other parts of the animal as well. But Face ID for animals is quite real. We can do this for almost any animal in the world, we think. In fact, we know we can. Here we have a hard use case for Face ID. And in this case here, you're looking at what is a type of a cow called a red Angus. And the red Angus cow, the challenge that you have with the red Angus is that they look all very similar. But if you actually stare at them for a little bit, you can see that they're actually quite a bit different. The head shape is different. The fur on the animal is different. And then when BETSY looks at this, she's able to distinguish what makes each animal unique. The one on the top left is the hair patch at the top. We can see why. On the one on the top right, it's the nose bridge. Something in the nose is unique on this animal that gives it away. And she does this and learns these features, I stress, all by herself. All by herself. And by doing so, she can do the same thing for Black Angus. This is probably one of the hardest use cases. With Black Angus, BETSY can tell who the animals are. We need some good lighting to do this. We can tell who the animal is by just looking at the head. We don't need the drop tag. And we can look at the unique features. So in this case, BETSY is saying for the one on the top left, it's the top and the bottom. There are two hot areas that give the animal away. And it's even more impressive than that. If you look at the top right, BETSY is actually using two different parts of the head to ID the animal. She's using the head, the top of the head, and in this case, the nose. And in the lower left, BETSY's actually learned how to look behind an animal or part of an obstruction. So in this case, she's looking behind the ear of cow 14B to identify the animal behind it. We didn't tell BETSY how to do this. Those of you who know that computer vision, we train AIs to do this. We trained BETSY to do this, and she learned these features by herself that make the animals unique. The power of that approach, of course, is it can be applied to any unique characteristic that makes an animal unique to its peers. It can be the spots on a Dalmatian. It can be the warts on the nose of a sheep. It could be a unique ear that exists on a piglet. It really doesn't matter. All that matters is that something is unique about that animal, and using our approach, our algorithms, we can tell what that is. We've been working on this for the past year and a half, and we think it is arguably, if not the state of the art, it is pretty darn close. From a technical point of view, for those of you that are in computer science, as you know, that ID algorithms project into hyperspace. So the way that actually looks like from a training point of view is like this. This here, I believe, is a TSNE graph. This shows an untrained projection of our hyperspace into 2 dimensions. Once we train our algorithms, this is what they look like on a TSNE graph. You can see how the IDs of each algorithm now grouped of each image that we use to train the algorithm are now grouping together into nice little zones that are easily differentiable in hyperspace. This is how ID systems work. This is how we do it for animals. And if you actually go down and look at that, the results of that, here's what that actually says. So in this case here, in this test case, we had 85 animals, images that we've not seen before. We asked BETSY to identify them. In this one test Jupyter notebook, she got it right 80 out of 85 times. The first one on the left, the image on the left indicates the truth. The one in the middle is the prediction. And the one is basically the group of the images that came from. So in this case here, you can see that she gets a bunch of them right. And you can see how she does so. And if I can find one here that's wrong, it should be in red. She gets a lot of them right. You can see why she gets some of them wrong. So in this case here, in this red Angus, they're very similar, and she couldn't quite figure this one out. Now, what I don't have shown here is the confidence score, but that confidence score would tell us when the guess is wrong. So BETSY not only knows when can predict the animal's ID, she also knows how right or wrong she is on the ID. And we use that to maintain quality control in our system, in our platform. But as you can see, BETSY can do this over and over and over again, and she can do it at scale. And she can do it incredibly fast. Once we have the ID of the animal, we then start doing all these various activities and classifications of what's important in the animal. We can track, for example, the activity. Is the animal standing, walking, sleeping, eating, or drinking? Does the animal have a certain age that we can predict? Does it have certain phenotypes that we want to track? Is the animal slouching, and so forth? And what that actually looks like, I'll give you an example of a video of that, is here. Oh, actually, before I do that, let me show you something. Another thing that we've done is also apply ownership to various parts of the animal in our vision. So here we're saying, as we look at this animal, we know who owns which hoof, knee, and body part. But we call this limb tracking. And as we do that, this is an older video, but it demonstrates that we can actually track the parts of the animals and who they belong to quite easily. You may think this is trivial, but it's not when animals are overlapping each other. And we put a lot of work into being able to track who owns which animal, knee point, and also tell when we don't know, which is equally important. Okay. Once we have the animal parts, we can do things like this. Here's a mother and a calf, and we could tell, for example, when this calf is suckling on a teat. We can see the teats and the udders. And when the animal's key point for the mouth crosses over to the teat and is on that teat, we know that the animal is now suckling. It's not hard to figure that out. That's what we do with BETSY. And BETSY does this with many, many different things at the same time. Okay. If you put that all together, this is one of our more presentation videos. This actually demonstrates the technology running as a pipeline on one individual. Watch this. So here we have what a human sees. Here's what BETSY sees for bounding boxes, layer 1. Oh, we've also added these things as well to our system, where we have a sort of a virtual information system appearing, where we actually pop information up on video to show what's going on with an animal. So you don't need to look it up. We call these things cow cards. We then compute and track the drop tag. We then do limb tracking, which you just saw. And then, of course, we compute the key points and the key angles, and here we go. And if you look here, it's actually quite amazing what you can see. Like you can see, for example, that the ears here are perfectly straight. When an animal is stressed or annoyed or frustrated, it might actually flicker its ears. That's an indication that the animal's not happy. We can compute that by just watching the ears change over time. How many times a second or minute does the animal, for example, flick its ears? Here's how we can see that. Okay. If you take it and apply it to it, well, the obvious question is if we do this, does it apply to herds? Can it scale? And the answer is most certainly, yes, it can. What you're looking at here is what a human would see at the herd level. Here again, we have a couple of cows. I'm not sure what they're saying to each other, but they're talking. And here we have the bounding boxes being drawn over a herd of animals. Oops. Here we have the face ID. And the face ID, of course, comes with confidence scores, so you can see them here. And once we have the face ID, once we know who the animal is, I haven't shown this to you, but we actually have a tracking system as well. And that tracking system allows us to track the bounding box of and who owns that bounding box as the animal walks around. So we know who that bounding box is, even if the ID is no longer available. We have tracking of ID, even though we no longer have to ID the animal up close. We also then do limb tracking. Here you can see this in working in play. And this is how we get so much data coming off these animals. Here we have the drop ID that we use, or the drop tag that we use as truth. And that tells us, of course, who the animal is for sure. And then in addition to that, we draw key points on the animal to give away the structure of the animal. This gives us the bone structure and the joints. And if the animal is slouching, for example, or exhibiting signs of lameness. And then we compute the angles of those animals. And again, we can do this at scale. This is BETSY. This is what BETSY can do today. And the beauty of all of this is that this is just the tip of the iceberg. You see, we can do much, much more than just track the stuff that you've seen here. Just like you can add another piece of functionality to a spreadsheet program or to a website, we can add another piece of functionality to BETSY's pipeline and expand what she can do. Once you build a new model to see something special in an animal, for example, counting tail swishes, that would be a good use case. We then can say, hey, let's deploy that to all our customers. And all we have to do to do that is basically modify our pipeline, add one more model, and BETSY can do one more thing with no new hardware. This is why this scales so incredibly well and is so cheap to run. And we're not just doing it for cows. Here we have it working on horses. And with horses, it's the exact same approach. Here we're doing key points on the horses. In addition to horses, you saw the sheep that we mentioned briefly. We also do, in addition to the sheep, we do the swine. You see the scale of this? This is where this is going. And in swine, we can even do really hard use cases. This is it just shows you how powerful this technology is. Like, just look at this for a second. Like, we're looking through the bars of a very complex scene, and in full frame rate, I'm able to cut apart an animal up with, obviously, with a high degree of precision, and do it reliably, frame in, frame out, even though the animals are easily obscured and under strange lighting conditions. That's how good computer vision AI has become. Here we're doing it for pigs. And we're not just limited to pigs. We're doing it for elk. Elk is actually a meat. We're doing it for bison. Some of our beta sites actually have bison herds. We have data coming in on bison right now. And to go back into Randy's question, we're even doing it for dogs and pets and companion animals. And here's us using it on dogs. Now, so as you can see, computer vision can be applied to livestock, to pet animals. We're doing this for fish next. We're doing it for chickens. There are many, many billions of animals in the world. We use our technology to help generate huge amounts of data And we put that data into a user interface for our customers to use. And that interface looks a lot like this. This is now a few months old, but each ranch has a map that tells you where everything is. Status of all their cameras, a list of all their videos that they can play quite easily, which you've seen before. And then once we have the videos, we process those videos using computer vision. And there are really neat things, for example, because we have the ID, we can actually tell where an animal appears in any video. We have an index to all the videos. And those not shown here, we can actually find an animal in all the video archive literally in seconds. That's the power of using Face ID. Here's some processed video coming off of the animals. And if you look here, even in this case here, you can tell that we're actually running some of our classification algorithms. We know that this cow, for example, is standing and it's an adult. Okay. Once we have the animals up, we then bring up information about each animal. We have these extensive data on each animal that we can demonstrate. And we also then, of course, can show where the animals are in videos and also show how often we see them. So we can tell, for example, when an animal has not been seen in a few days and where we last saw them in case the animal is missing. We display our videos, of course, to our customers that they can search by date range or by whatever criteria they want. And they can look at the process footage as well if we save it for them inside of our portal. But one of the most useful aspects of BETSY is the alert system and the notification system. BETSY is much more than just passively collecting data. She is proactively looking for problems. And when she sees a problem, let's say a calf is being born and it's in breach, she will text somebody and say, hey, we have a problem developing right now. Okay, so BETSY is proactive. And when she finds a problem, she tells somebody. She doesn't just collect data. She actually tells people when things are going sideways. And we have lots of other cool technology that we have inside BETSY. In cases of low bandwidth sites, we do time-lapse videos like this that allow us to provide nice overviews of what happens at a ranch in a day. This is one of our ranches south of Calgary. And you can see here, even though the animals are far away, it gives you a nice 1-minute overview of what happens in your ranch on a given day. We create footage like this to summarize visually for a user what goes on. You can even watch the satellites go by at night. It's quite interesting. In addition to that, we also have a mobile app that runs both, that we're putting together both for Android and iOS. And the mobile app effectively mirrors the functionality of the website with one key difference. The mobile app that we've created builds shipping manifests. So as BETSY is being used to track animals going on to and off to shipping containers like a truck or a rail car, we can then create shipping manifests that can be mailed off as PDFs, again, powered by computer vision. So BETSY is an artificial intelligence that is providing several value propositions to ranchers, feedlots, and so forth. And she does so in a way that can be done both on the desktop and on the mobile device, summarize the data for the humans quite easily, and take that information and act upon it in a proactive fashion. And when doing so, we are generating Face ID. Our mission as a company is to create Face ID for all animals on Earth. And we're well on our way. One of the things that makes us different than other companies is that we also are very happy to share the information with other companies as well, if the owner of the ranch allows us to do so. So we are building what we call an open system, or we also call it open science, where people can pull information from our massive databases and use it in their own internal analytics tools. And by doing so, we are basically enabling many people to use BETSY. It doesn't matter which software you use. It's not our mission as a company to replace other companies. That's not what we're trying to do. What we are trying to do is enable them to be much, much more with the massive amounts of data that we can collect. There are tools out there that are far better than ours in analyzing data. We have good tools, but other people have better. So we are happy to share our information that we collect with BETSY with third-party applications and with other companies to enable their tools to be better in managing herds. And with that, I think I'm going to wrap up my talk. It's 11:50 or 12:50 your time. Are there any questions, anybody?
I always have questions. I have a few more, but I'll let someone else go first.
Can I ask a question? Are you guys shocked at what you saw today?
I'll answer no, but then I have inside information.
That's true, Randy. Have you guys seen anything like this before?
In fact, that's part of my question, Jeff, is I just sent you a link to a presentation that I did with Patrick Pilarski at a conference in Japan on skill science. One of my dear departed long-term colleagues in Japan, Koichi Furukawa, developed a whole history and became the leader of something that was called skill science, which was the application of machine learning to performance skills to be able to make predictions and to be able to educate people to improve their performance. To give you an example, he was an amateur cellist, and he systems that scanned and classified the articulation of bows in cello playing, and then wrote a book that every cello player uses to improve their cello playing. Now, the reason I sent you this is because it seems to me that's a sort of perfectly aligned with the trajectory you have about multiple animals. So if you take a cello player or a baseball pitcher or other things like that, where there's some, if you like, context specific modeling at the right level of granularity that helps you do an analysis of the performance, then you already have a leg up, and all you need is the subject matter expertise to guide it. So I've sent you that link, and we can have another meeting about it because it's in quite detail with lots of videos and everything. But the bottom line is that what he did is studied, for example, videos of a variety of cello players to be able to classify their cello playing and how they performed certain kinds of cello playing techniques like spiccato, and who did it better and why. So we can have.
That's a really interesting discussion, actually, because it brings up a really good point, Randy. Like, if you can train a model that identifies what makes a cello player or a golf swing the best golf swing,
Absolutely,
and you then analyze another person's golf swing or cello playing and see the subtle differences that make the key difference, that they may spend 10 years trying to work through.
And the connection with Patrick Pilarski's lab and reinforcement learning for learning how to use sophisticated prostheses was part of this, because Patrick is leads in the instrumentation of humans as animals to be able to do that calibration. So we have lots to talk about, but I won't use up the rest of this time to do so. We connect frequently enough, so we'll talk.
Let's connect after this talk and let's have a further discussion about that. I find that quite a fascinating concept, because you're quite right. And this is one of the reasons why we have so many cameras out there. Like right now in the field, well, we'll soon have 300 cameras running or up at some stage of being set up. And in doing so, we have all this data coming in, and we have all these edge cases coming in. And we can find out what makes a good animal versus a bad animal, or what makes a good investment for livestock versus a bad livestock investment. And we think by collecting all this footage, grant you it's millions and millions of videos in the end of the day, it doesn't change the fact that if you analyze them using computer vision, you can find out what's a winner and what's a loser, what's not effective, right?
Yeah, absolutely. Yeah, it's almost the educational value, like rehab, better cello playing. I'm old enough and have injured my shoulders too many times, so I will never again throw a good curveball, but that doesn't mean there isn't an analysis of why.
Or we can make also teach a cow to play the violin too, right, Randy?
So I've sent you that link. Have a look at it, and then next week we can arrange a discussion, Jeff.
Okay, I'm going to start burning through the questions here on the side. I'm going to start at the top here. It's one of the questions is how is this being applied with humans? Is your company pursuing any human applications? Yes and no. We can see how it can be easily applied to humans, for example, who's being safe at a ranch. We can see how that can be done. Is it a priority for us? Not at the moment. The reason is simply this. Humans have privacy rights and privacy issues. Animals, generally speaking, don't have privacy rights. It's just easier to do the animals. So we are not doing humans, though we're not ruling it out. Right now, when we see a human, we have the ability to basically block them out or ignore that footage. Our focus is animals, but we can process the humans just as we do the animals. It's not a big leap from the technology application point of view. Second question, rural high-speed broadband surprises me. Since the beginning of the pandemic, it seems like it's been a challenge. Rural broadband has been a challenge from day one. This is why the industry is sitting in the 60s and 70s. It's very hard to get even phone coverage on a lot of ranches. When you drive down the middle of Saskatchewan and you're on the highway and you get LTE phone service, that's the highway. Okay, you go 10 miles north or south from that highway, it's not there anymore. There are huge swaths of the country that are not covered with cell phone service and that do not have high-speed internet. And it's not just Canada, it's worldwide. That's why Starlink is going to change the game on a massive scale. They have 2 megs up and 10 megs down. We have tested many, many ranches. They all have very similar throughput. That's not even getting into how when it cuts out and stops working. They just do not have quality internet. What you see in the cities and what you get in the country are 2 radically different things. Nice question. Also, speed of processing. How do you process and analyze visual information to a degree of automation? How much of this possible because of automation? I think the question is here, how can we automate everything? The answer is that we automate everything. That's the whole point. If we have to do any of this by hand, it's not going to work. So the learning of the unique identifications that make an animal, that's all done through an automated process. We don't tell Betsy how to do her job. We teach her how to do it, and then she does it. She learns how to create an ID space for the animals all by herself. She learns what features make them unique. So that whole process of building an ID landscape and validating it being correct is done in a fully automated fashion. That's how this thing scales. Does OneCup AI share data with researchers working at university? If so, how does one start the process? It's easy. Email me or email the CEO of our company, and we'll find a way to make it happen. We are working with many researchers right now at colleges and other places in Canada. We would love you to work with you as a researcher. The amount of data that we can generate and produce for you is simply massive. And we can do it through an automatic fashion. I know for a fact, for example, that's somewhere in Alberta, someone's being paid to count tail swishes on a cow. Let us automate that for you. We can make that very easy to do, and we can do it across many, many hours of footage or days of footage in a matter of minutes. Nice question. Thanks for interesting presentation. This is a long question. The question is about the Face ID application. Your model makes use of clues like fertile, which is called spurious correlations. And researchers are trying to prevent models from making use of those patterns. Although your application is different, I would suggest you have a look at literature to know about the issue of these patterns and how to avoid them. I think the question is here, and let me address it to a point, is let's say you take the ID of a cow and it has a unique fur pattern on its head, and Betsy learned by itself to see that pattern versus, let's say, a wart on the nose. And let's say someone shaves the head of the cow. That fur pattern is gone. Betsy, in theory, would have trouble IDing the animal, and that is correct, she would. She'd have to relearn the ID system. What we do with our ID system is we retrain the ID system roughly once a week, and we track the confidence scores as she's doing so. So we know when her ID is beginning to degrade. So if things happen on an animal, let's say there's snow on it or mud, and we need to retrain or it's getting older, we do so. And it's not that we try to stop Betsy from learning one thing or the other. We let Betsy figure out what is the best thing to identify an animal, and she retrains on a continual basis and tracks her accuracy over time to see if it needs to be trained on a more regular basis or less regular. So we sort of have a process built in to address that. I hope that answers your question. More questions. Can you analyze animals from public videos, or do you need to capture them with OneCup cameras? The answer is, it depends. We prefer to use our cameras because they do exactly what we want. However, Because people have cameras already installed in many ranches, can we use those cameras? The answer is yes, we certainly can. Footage is footage. The only problem with the older cameras is that if they're at a really low resolution or bit rate, the quality of the image may not be sufficient for us to run Face ID. We can do classifications fairly easily on activity, but if we want to track individuals at the herd level, we prefer to have higher quality cameras, but we certainly can use any camera in the world within reason. I was looking at footage, for example, on swine just yesterday that was coming off a camera that was about 10 years old and was only 640 by 480. And we are pretty sure that our base model will run on it quite well. So we can use any camera, which means we can deploy this technology worldwide where cameras already exist. Randy, thank you for the comment.
No, just thanks a lot. I appreciate the content and sharing it with everybody. Good talk. Thank you.
Well, everybody, it's now noon. Thank you for all your time today. I appreciate the opportunity to present. If you're interested in joining OneCup or being part of OneCup, please send your CV our way. We just hired 10 more people. We'll probably need more. There are a lot of animals out there and a lot of models that we need to build, and it's a lot of work. And there's a lot more projects that I haven't spoken about that we're doing at OneCup. So if you want to be part of OneCup, please reach out to us. We think this company will be big. We think it's got huge potential, and we're looking for skilled, motivated people that love animals and want to take machine learning to what it can be. So thank you. Thanks again, everyone.
Thanks very much for presenting today. And thank you everyone for coming to listen to the presentation. And if anyone does want to have a further chat with Geoffrey, he does have some time for the next hour or so. I sent out an email about the other day, but if anyone has figured out they have more time in their schedule or have come up with things they want to discuss that came up during the presentation, feel free to let me know and I can help coordinate if need be. Thanks again, and we will see everybody next year for the next AI seminar.